Good afternoon, dear students. Last lesson we were talking about determinants of matrices, and now we're talking. Our current lesson will be about matrices. So let's just check your knowledge from the lectures, and let's remember what matrix is. So who wants to answer? Who will be the first? Maxim, yeah?
Matrix is a rectangular array or a table of numbers, and it can be designated as a matrix M times N.
Correct. Okay. And the next question, which operations can we do with matrices? Who will be the next? Daniil, yeah, go on.
We can multiply matrix by a number. We can multiply matrix with each other if they have the same quantity, amount of column and row. And we can multiply matrix by a row, subtract or add them also.
Okay, I will correct you. Actually, we can add and multiply matrices which have the same dimensions. And what about multiplication? It's better just to illustrate. Just a moment. Let me share my screen. So my app for drawing is not responding. Oh, now it's okay. So, how to multiply matrices? Actually, we can multiply matrices if their properties are the following. So we have matrix N1 by M1 and matrix B N2 by M2. And we can multiply them only if M1 is equal to N2. So if the matrix from the right rows numbers equal to so if left matrix not rows, but if left matrix columns number equals to a right matrix rows number, and what will be dimension of their composition? Who can answer? So,
can you repeat the question?
What will be the dimension of composition of these matrices? So how many columns, how many rows?
It will be the size of M1 and N2.
N1 and M2, right?
Yes.
Yeah, so it will be the result dimension. Correct. So like, so just logical question. Are matrices commutative? So does equal A multiply B equal, so does it equal B multiply A or not?
No, it isn't.
Yeah, in general case, not. But there are some matrices that we can change their order, and if they're equal and their composition is equal, they are called commutative. But it's a partial uh, case. Okay, what else can we do with matrices?
Transpose them.
Yeah, transpose. And what does it mean?
Like we change the number, like the columns and the rows places.
Yeah. So we just change their places, and the typical mistake of beginners. How do you think? Only can we transpose only square matrices or not only square?
I think we can transpose all the matrices.
Yeah, you can transpose any matrix. Actually, it's just a mistake that usually beginners make. So it's good that you know about it and remember. Okay, and what else can we do with matrices? Who will be the next? Important operation. Daria, yeah, go on.
We can find the inverse matrix.
Yeah, we can find inverse matrix. And what is actually inverse matrix? So which properties it has. So we write in such way. Who can help? So if I multiply inverse matrix by just a usual matrix, so what will we have? By the way, can we commutate them or not? So
Identity
who can
matrix.
answer? Okay, Daria, continue answering.
Multiplying these matrices, we will get an E matrix, which means identical matrix. It is matrix which has a number 1 on the main diagonal, and other numbers equal to 0 has 3 rows and 3 columns.
Yeah, so all elements except the main diagonals are zeros. And actually, such operation, so multiplying by inverse matrix is commutative. So we can change the order if we need. Okay, so now let's do some exercises, and let's start with simple exercise. So actually, the first question, can we add matrices A and B and A plus C? Is it possible or not? Okay, no, I want a new person to ask, to answer, sorry. Uh, so who, oh, Yevhen, yeah, go on.
You can add two matrices if they have the same amount of dimensions,
So,
same number of dimensions.
so which of them can be added?
So
Yevhen, you
matrix
can.
A can have to be
Sorry.
Uh, you can add A to C, and you can add A to D. The same for C and D, but you
Mhm.
can't add it to B.
Yeah, so definitely B uh, is like an odd matrix here. So now let's start with adding A and C, and you can do it in your own individually, and then we will compare our results. So actually, it's almost nothing to calculate, but anyway. Okay, and actually, who didn't answer? If I'm not mistaken, Alexander wanted to answer. Alexander, so
Alexander Dolmatov.
Domatov, yeah. So yeah, I see your surname. So now you can answer. Your turn.
Okay, so my answer is for the question A actually. So
Yeah.
A matrix plus C matrix equals 0, 4, 8, 8, 7, minus 1, 7.
Correct. So it was easy. Maybe someone is ready with B, or you need some time for that.
We need some time.
Okay. So let's wait for 2 or 3 minutes. Okay, Stanislav is a new person, so go on.
I got the matrix 13, minus 2, minus 10, minus 24, 4, minus 5.
Correct. So by the way, what is element on the second row and the second column?
minus 24.
Yeah, correct. Okay. So it was quite easy. And actually, yeah, the answer is correct. And now it's time to multiply matrices. So firstly, let's multiply A plus C, but yeah, let's do it together. The first, so A part, and A multiply B, you will do in your own. A little bit slow today. Okay, so multiplying A by C. Now, let me zoom just to see it better. What's happening with my mouse? Okay, so what is so first of all, what is the dimension of the matrix that we will have?
It will have 2 rows and 1 column.
Yeah, actually 2 rows and 1 column, so it will be a vector. Oh, yeah, we will have to calculate in details. So let's calculate together. Oh, just a moment. So just a minute. I need to do something with my mouse. I can't work in such situation. So it's a little bit laggy, slow. Okay, now is better. So let's calculate together. So what we will write here. So how do we actually multiply? Who is going to answer? Let's see. Actually, I want to hear someone new from you. So maybe does anyone want to be a volunteer or not?
So solve it, or what do you mean?
solving together. But anyway, you already answered. I want someone new to hear. Okay, maybe Masha.
Yep. Okay. So we multiply first row by the column, right?
Yeah, it's correct.
1 multiplied by 1,
Yeah,
1
so actually 1.
plus 0 and minus 6.
Yeah, so we will skip 0 and 1 minus 6. Correct. Okay, and the second row.
3 plus 18 and minus 15.
Yeah. 3 plus 18 minus 15. And the final answer is
Minus
minus
5.
5. Yeah, minus 5
6.
and 6. Correct. So actually nothing so difficult, so don't be shy to answer. And now let's solve the next example, the next exercise, part B. So A multiply B. Let's solve in your own now. Adrian, are you ready, right?
Yes.
Well, okay, let's give few minutes for everyone to solve, actually. And then we will continue. Okay, maybe anyone else? Anyone new? Okay. Yeah, Artem, it seems, if I'm not mistaken,
Yeah.
you haven't answered yet. So what is the result?
The result is minus 1, minus 4, 6,
Mhm.
42, 45, 80.
Yeah, correct. It is this answer is correct. Okay. And now what we are going to do, so we will combine using operations with matrices that you already know, and we will do the next exercise. Just let me share my screen. So you will have to calculate this polynomial, polynomial function where the argument is a matrix. So actually, what does power of matrix mean? So how do you understand? Actually, it should be easy. Okay, Daria?
Matrix multiplied by itself.
Yeah, so just multiply by itself like a real number. Correct. Okay. So, by the way, which matrix can be raised to power? Every matrix or not?
Only square matrix.
Yeah, only square matrix, correct. So, yeah, so it's good that you are so attentive. So let's let's calculate it together. So, because a lot of calculations. So firstly, what we will do, just raise matrix to the power of 2. Why it's so slow? So A2. Okay, actually, when you multiply matrices, it's a good idea to write everything in details. Okay, so actually, the dimension of the matrix, of course, will be 3 by 3, but let's calculate its coefficients. So, what is the first element? So on the first row and the first column. Okay, so who can help me? Okay, actually, all of you can take part. So for this cell, okay, let's start with Stanislav.
It will be 1 minus 8 minus 9.
Yeah, 1 minus 8 minus 9. Let's write in details for now. Yeah. And for this element, who wants to be the next? Okay, Adrian.
It will be -2 plus 0 minus 6.
Minus
Repeat.
just Yeah, -2. Yeah, yeah, correct. -2, -6. So we will skip 0. Yeah. And okay, who will be the next? Dmitro, yeah.
So the next one will be -3 plus 2 and 0.
-3 plus 2. Okay, and let's go on. This row.
It will be 4, 0, -3.
Just 4 minus 3. By the way, so let's answer somebody new. Artem Orlov, if I'm not mistaken, you haven't answered yet. So your turn. Artem? Okay, maybe something with connection. So Denise? Some of you are afraid. Okay, so just who is a volunteer for now? Okay, Adrian?
It will be -8 plus 0 plus 2.
Yeah, -8 plus 2. Stop. -8 minus 2. By the way, we multiply -1 by 2. So -8 minus 2.
Oh, I'm sorry, I skipped the minus.
Don't worry, but be attentive in the future. Okay, who will be the next? Maxim?
That would be just -12 in this
Yeah,
cell.
-12,
In this
yeah,
cell.
yeah. So just skip zeros. Okay. And what about the last row? Okay, Artem, Turchin.
It will be 3 plus 8.
Yeah, 3 plus
8.
8. Yeah, 3 plus 8, correct. Okay. Daria?
-6.
-6. Yeah. Masha?
-9 -2.
Yeah. And now we will calculate it completely. So here is -16 -8 -1 1 -10. By the way, do you see the canvas well, or should I zoom for you?
It's fine.
Okay. 11 -6 and -11. Okay, and actually what we have to do the following. So plus we need to multiply this matrix by 2 and then add 3x and minus 5. Okay, how to add some space here? Maybe I can change it to dimension or not. It would be nice if I could. Okay, let's continue in Paint. For now. So if we multiply matrix by the number, what actually we do? Who will answer? Adrian, yeah?
By multiplying all the units by the 2.
Yeah, so we just multiply all cells, all coefficients. So let's multiply. So minus 32, minus 16, minus 2, 2, minus 20, minus 24, 22, minus 12, minus 22. Okay, and let's add so 2a in the square plus 3a. Let me check if we need to add 3. Yeah, so 3a. Okay, let's calculate together. So what do we have here? Remember that this is matrix A. How it looks like. So who wants to be a volunteer? Daria?
Minus 32 plus 3, it will be minus 29.
Yeah, minus 29. Here. First row, second column. Adrian?
Minus 22.
Minus 22. Yeah. And here. Now Daniil.
Minus 11.
Minus 11. Correct. Here. Adrian, go on.
14.
14. Yeah. This coefficient, Daniil.
Minus 20.
Minus 20, yeah. Too easy. And here, Adrian, yeah.
Minus 27.
Minus 27. By the way, involve yourself. So start a discussion Who hasn't answered yet? Who wants to continue?
$31.
31. Right. Yeah, 31. Okay, next. So
-6.
-6, yeah, so you can answer now just without raising a hand, and this one, so just who will be the first?
-22.
-22, correct. Okay, and what do we see in this equation? Not equation, but a function. -5. So what does it mean? So how can we add a number to the matrix? Do we actually, so can we actually do it or not? So how
We can't.
we can add or cannot?
We need to calculate matrix and after this add no, -5.
By the way, what are you going to add? So, do you want to add -5 to each element, or how it will look like?
I mean, calculate matrix by rule of triangulars, and after this, and this number, add -5 for this number to this number.
By the way, we use the rule of triangle for the determinant, but we don't use them here.
But this is square matrix, and we can use, I think.
We don't need them here. So actually, we cannot add matrix to the number, but what it means in this case, we actually so instead of number, we use identity matrix. So in this case, -2a square plus 3a minus 5e. So we subtract 5 identity matrices from this. And now let's calculate. So just all together. So who wants to help me? By the way, do you hear me or not?
Yes, we hear.
Yeah. So just don't be afraid to answer.
-34.
-34, yeah. Actually, these elements won't change. This as well, and here.
-20.
Yeah, okay, yeah, answer together. So -27, nothing changes. And here. And here. And what is the last element?
-27.
-27, -25.
You just lost -22 at the last element.
But here we have -20.
No, we have 22, -22.
We
If you
have
round,
here
it's right.
22.
Yeah, so it just was my mistake. Thanks for your attention. Okay, and let's check. So the final answer here is, yeah, so actually everything is correct. So nice job. And now we'll have a break for 5 minutes, and then we will continue on calculating ranks of matrices and also inverting matrices. Okay, let's continue the lesson. And now we will calculate rank of the matrix. By the way, what is the rank?
Rank of the matrix is the largest order of non-zero minor of this matrix.
Non-zero what?
Non-zero minor,
Yeah,
you know.
that's
this
correct.
matrix.
Okay, and now let's calculate the rank of the following matrix. Let's go with bigger size. Yeah, so it uses a lot of RAM. That's why not responding. Okay, so let's continue in Paint. Save our time. So let's close it. Actually, we have to use the memory accurately. So it was a bad example of using all your programs. We'll continue in Paint. So currently we will use the definition of the rank of the matrix, and now we just we will find the minor. We will find minors of these matrices, and then we will know the rank. So this matrix actually is non-zero, so not all elements are equal to 0. So that's why the rank of matrix is so it is not 0, because for example this is not non-zero. But what about the second order? So can the rank can it be equal or greater than 2? So how can we calculate? So which minor will you choose to check? Mykola?
Can I answer?
Yeah.
I choose first row and fourth column,
So,
-1.
This so but we use we can use now we use 2, so this one, correct?
Yeah,
Okay, yeah, so let's check this
-1 is not equal 0, so it is at least first rank. Then we choose 2 minus 1, 1, 2. If it's not equal 0, 2, so at least second run.
Yeah, so and it equals 4 plus 1, so 5. Yeah, and what about the third?
What?
Yeah, about the third order.
Oh, it's equal 0.
Why?
Because all in a column is 0.
Yeah, so just remember such property of the determinant that if one column or one row of the determinant contains only zeros, the determinant equals 0. Yeah, correct. So the rank of matrix A equals 2. Correct. And now we will use the method of bordering minors. Well, actually, here you can see the spoiler. Okay, and
Can I ask a question?
Yeah, you can ask, definitely.
Shouldn't we use to find the M2? Shouldn't we use minor which contains M1 element?
Which minor? This?
The M1 we used to find the element A11.
Yeah, actually we can use
But
minor.
shouldn't we use that element 2 in the M2, in the minor 2?
Okay, maybe I'm not correctly understanding you. Let me.
Can I say it in Ukrainian?
Okay.
Чи не мали б ми використовувати перший елемент першого стовпця і row, щоб для другого мінора, вибачте. Чи ми можемо обрати будь-який інший майнер, який не буде містити в собі елемент цей?
Я зрозумів питання. Ну, ми можемо будь-який використати. We can use any minor, but if we calculate for this element, so here we have zeros, but we can actually use this minor. And so how in this example, it doesn't matter. We just need to verify that it is not equal to 0. So any you want.
Thank you.
Do you have any questions about it? Maybe someone else?
Yeah, I have.
Yeah.
We can use last minor 0. Can we sort without a second column or in right variant?
Do you mean use this minor, right?
Yeah, all except row is 0. Not row, column.
Yeah. Yeah, we actually can use this minor. It won't be equal to yeah, we can use this minor. It won't be equal to 0. So 9 minus 4, why not? Actually, it doesn't matter. So
yeah, but it's still 0. I sort. So first,
I don't understand what you mean actually. So we can go with this minor.
No, I was about go far. Use third.
Yeah, the third minor.
Except
yes.
Second column.
But anyway, so if we use this, so because all zeros in this column actually we can take also this minor. Yeah, we can't actually take from different parts here, just only minor. So we go continuously. We can't separate it into pieces.
Okay, this was I'm asking. Thanks.
Okay. But let's, oh, no, yeah, so it was incorrect from my side. Yeah, actually we can take any minor, but let's verify it. So let's clear this file. I will clear my annotations. So let's calculate, for example, so yeah, like this minor.
Equal to 0.
Yeah, it will be equal to 0, but let's verify for this case. So 1, 3, 4. So here we have 1 plus 8. Oh, no, not 8, plus 16. Minus 9. Plus 4. Minus 6. Minus 8. So 21 minus, something is wrong here.
Minus 6, minus 6.
Yeah, minus 6, minus 6. My bad, actually. Yeah. So in the evening, in the end of work day, losing some attention. So yeah, it equals to 0. And what I wanted, what I was telling you about before, actually it's the method of bordering minor. Just so instead of selecting any of them. So what is the idea? That we choose any minor that not equal to 0. So this one, let's just look at the example. So this minor is not equal to 0. It equals it equals 2. And then we use the border minor, so we can use either this minor or this. It's just to simplify the work. So in this example, we use this one. So 2 minus 4, 3, 1 minus 2, 1, 0, 1 minus 1. And actually this minor, let's calculate it together. So 4, so here will be 0. Let's write it. 4 plus 3 minus 0 minus 2 minus 8. And it equals minus 3, and it doesn't equal 0. so lost the level. And now, so we can see that the rank of this matrix is equals or greater than 3, because we have minor of the third order that is not 0. And now it's
So
clear.
to find the rank of the matrix using the method of the bordering minors, we need to expand the previous minor and check it if it's not 0.
Yeah, so
Or not.
actually, yeah, that's correct. So firstly we take this minor. It's not 0, and then we expand it in this way. It's not
Or
0
maybe
as
to
well.
the right side, yeah?
Either left or right side, any side you want. So if
Okay, thank you.
this minor equals to 0, it means that the rank of the matrix is 2. So you won't go far. But if it's if it doesn't equal 0, you continue the algorithm. So this minor, and actually for this minor of the third order we have no options, we just take this minor. So of this the fourth order. Do you have any questions maybe for now?
No questions. at the
Okay,
moment.
no questions. And now I will clear all drawings and let's continue. And actually, so you remember how to calculate determinants for the fourth order, and actually we won't do it now, but maybe let's check, maybe we have some, so it has some properties that so maybe equal columns or rows or proportional, but I don't see them. But actually, yeah, so if it equals 0, so it means that we stop calculating the rank. Anyway, the matrix has four rows and 5 columns. It cannot be greater than 4. So the rank can be equal or less than the least dimension. So for this matrix, the rank is 3. And now yeah, also we can use we can find the rank of the matrix with the elementary row operations. We just transform the matrix here. You remember how we were calculating determinants. So we were transforming the matrix to the triangular. So we're transforming determinant to the triangular view. Do you remember, right? So here is the same way. How do we solve? So we multiply 1 by -5, and so we subtract this. So from the second row, we subtract the first one multiplied by -5, and here we have 0. So we just set zeros except everywhere below the first row, and we have the next matrix. Here, what do we use? We actually, yeah, in this matrix, we take this row. Let me annotate. We take this row and subtract it from this row, and from this row multiplied by no, not multiplied. Okay, I'm explaining you not correctly. So yeah, so we subtract this one and from this and from this as well, but here is something not correct. We just subtract from this line, from this row, we subtract this and this, and here we have zeros only. So 11 minus 6 minus 5, 0, minus 10 plus 3 plus 7, so 0, minus 24 plus 13 plus 11, 0 as well. And if we add 19 and 15 to minus 34, we have 0 as well. So here we see that we actually cannot have the rank greater than so equal than 4 or greater. So it either 2 or 3. And then we need to eliminate this row remaining. And here we have such minor which remains. And then we just calculate it and check if it equals to 0 or not. So any questions or not? Is everything understandable?
No questions.
About this way, this method. Actually, we have not a lot time, so currently skipping this example with details. And now let's move to
We already knew.
Sorry?
Well, we already have known this on lectures.
How? So you didn't have lectures about it yet?
No, we had. Already had, and we already knew.
Oh, okay, that's great that you have such experience. And have you experience of inversion inverting the matrix with elementary transformation or not?
Not in practical.
Okay, so you didn't have such example with the inversion with inversion matrix, but with the rank calculation you had. Okay, so let's calculate the inverse matrix for this one. So firstly, we expand our matrix with this identity matrix. And then we start transforming it as well. So as you are transforming matrices for in other exercises. Oh, it is not equal. Just we can use either this like tilde sign or just an arrow. But this matrix of course won't be equal. So firstly, I divide the first row by 3, and I divide this matrix and this as well. So the whole row, main our matrix and expanded one. So 2 by 3, 1 by 3. And here 1/3. Here just zeros. And here I need to set zeros. Okay. So actually I will transform this matrix to identity matrix and this to inverse. Okay, so how do we get 0 here? I just multiply 3 by 3/4 and subtract it. And what about 5? So okay, I don't like actually working with the fractions, so let's look at the example. Because we will do a lot of mistakes and I don't have enough space. So what do we have here? So the first row is divided by 3. Just divided by 3. And then I multiply it by 4/3 and subtract it from this line. Then I multiply this row by 2/3 and subtract from this. And I set zeros here. And I do it with this matrix as well. Then and then I do the same thing with the second column. But I actually need to set 0 this here and here. So I need to transform this matrix on the left to identity one. So here we have zeros. And do analogically, so here we just divide this row by 7/3. And now what about the last line? Last row we divided by 24. Cool. 24 by 7. Interesting, actually. But it's just a coincidence. I was not looking for such example. So we divided by 24/7 and then here we have we subtract from this with multiplying multiplying by the respective coefficients, and we obtain identity matrix, and this matrix is the inverse one. And now let's just verify that this matrix is inverse. Because without verification, you won't be sure that the result is correct. So let's calculate together in the paint. Save it. Maybe you know other ways of calculating inverse matrices. Adrian, yeah?
I know the easier way, but it's longer. We just transpose the matrix,
Mhm.
and then for each element we find the capital A. I don't
A
remember the name.
cofactor or
Cofactor, yes.
algebraic complement.
Yes,
Yeah.
and for me it's easier, but it's take a long a time. It's taking a time.
Yeah, actually we will do it on the next lesson. We will use inverse matrices for solving systems of linear equations. Okay, so now let's calculate. So let's write in details. 9/4. But by the way, yeah, you can take part as well. So who will join? Who will join discussion? Mykola?
Plus 6/4. Am I right?
Just more, yeah, plus 9/4 plus what?
No. Unfortunately, I don't know. Really, I'm not so confident.
Who can help? Okay, Adrian was the first, then Daniil.
Minus 28 divided by 24.
Minus 28 divided by 24, but it's actually 7 minus 7/8. Yeah, so we can write it shorter. Yeah, and then
Minus 1/12.
minus 1/12. Actually, if we calculate it, so the common yeah, so 12, so it will be 14/12, and here so by the way,
27/12 minus 10/12.
yeah, okay, so yeah, everything is seems to be okay or not. So we have to get one here. 27. Oh yeah, so correct. Here 27 minus 14 minus 1, and it will be 12. So here is 1. It equals to 1. We have not enough time to finish it, but let's calculate one more cell just to verify the result. So what we're going to write here? Let's calculate together. Just one more cell, and you will have a rest. Did anyone raise hand? I don't see. Daniel? Yeah. Actually wanted to answer the next. Yeah, Daniel, go on.
So 3 seconds. 3 seconds.
Mm-hmm.
Minus 35.28.
Mm-hmm.
And minus 128 or 24.
By the way, minus 35.28. Are you sure?
24, yes.
Yeah,
24.
so yeah, that's incorrect here because it was incorrect. And so here, what we actually have. Why it's so thin?
0.
Yeah, actually, here we have minus 36/24 that equals to minus minus 3 seconds, and actually this expression equals 0. Maybe you have some questions for now or not.
Will be this information in on the university website? The
Yeah, sure.
presentation.
Actually, yeah, the first practical lesson is available for you. So here you can see video. So that's for your group recording, and the presentation for the first lesson is below lectures. So this presentation, and today or tomorrow I will share the next one. So for this lesson, and video as well.
Okay.
Anything else?
That's all.
I asked about filling the journal. First time
Yeah.
Can I ask in Ukraine?
Okay.
Там перша тема у нас була вступ і вступ функції на члени, але ж ми робили лише другого та третього порядки. Нормально мене чуєте? До мене вибило вже.
Погасіть краще відео, бо не дуже.
Та я без відео, так. Я не бачу.
Ну, визначники ми для 4-го порядку робили також.
Да, ну я маю в виду, що тема у нас там Вступ функції многочлена – це як перша тема, а далі йде визначники другого та третього порядків. Яку мені краще там дату записати? Це в цьому питанні.
Дату, яку для чого? Не зовсім зрозумів.
Просто тут перша тема йде як вступ функції та многочлена. Я ж зрозумів, що вона має бути першою, як і по даті також. Але ми ж проходили визначники другого та третього типів, і за тему я кажу. Я поставив на ці дві теми дві дати однакові. Це неправильно, чи як краще зробити?
Та, в принципі,
Нормально.
це не так важливо насправді. Чи може це ви плутаєте ще з лекційним матеріалом? Лекції ж.
Ні, там окремо.
Ну, ви можете записувати, як вам зручно. До речі, ваше індивідуальне заняття там, от в першому модулі, якщо я не помиляюся, то у вас все починається з визначників, потім матриці, тобто функції многочлена, це буде у вас трошки пізніше, більш детально. Ви встигнете з функціями напрацюватись.
Розумію, просто на мене стоїть як перше, тому я і спитав, щоб я.
Напишіть, будь ласка, на пошту мені. Можливо, я не зовсім розумію, що ви маєте на увазі, там зі скріншотами, можливо. Щоб було краще зрозуміло. So, anything else, dear students? Do you have any questions?
I think everything's clear.
There are no questions over there.
No questions?
No.
Okay. So, have a nice evening, have a rest, and stay safe. Bye. Have a nice evening. Thanks for your attention.
Goodbye.
Thank you. Goodbye.
Thank you for listening. Bye.
Thank you for the lesson, also for you.
Thanks.